Hi, I'm Alexis. I'm CTO at Numberly. Numberly is a digital marketing company that helps brands establish a digital relationship with their customers and prospects through the usage of data. Talking about data, of course, we have been using MongoDB for over 10 years now, and Scylla in production for like 2 years as well. So I wanted to share about this experience, all the things that we learned from an ops perspective to a developer perspective. And I really hope that you enjoy the video. I'm really happy to be here. We'll share some field experience on MongoDB and ScyllaDB. I will start with the traditional, who am I? I'm Alexis. I'm a CTO at Numberly. Numberly is a marketing technologist that is helping brands create a digital relationship with their customers and prospects through the usage of data. I've placed a lot of hints in this slide so that you can pinpoint about where I live, in case my accent already tells you that. As Greg said, I'm a Gentoo Linux developer. I've been in this field for like more than 8 years now, where I have the pleasure of packaging and looking into the source code of things like MongoDB, Redis, and of course, Scylla. I also package and have a special interest in cluster-related technologies and their Python bindings. So I'm an open source enthusiast and contributor. I've been contributing to Scylla. I have some 2 PRs open actually at the moment, so please guys. That was my cue and the right time, I guess. I'm a PSF contributing member, which means that I spent a fair amount of my time contributing to various Python-related projects around the world. And when I'm at home, I'm teaching my kid to love Scylla as well. And as you can see, she is really supporting the technology and all the low-level design decisions behind it. So, thank you, guys. Let's start with a bit of history, because it's important to know where those technologies come from. So, it's already been a decade since Cassandra got open sourced by Facebook. And a year later, MongoDB got open source as an AGPL license at that time. The company behind it was called Tengen. Then MongoDB reached 1 year later, in 2010, the 1.4, which was the version that was known as production ready. And it's at the exact same time that Numberly started adopting in production MongoDB. So that tells you that our risk management and early adoption motto is very strong at Numberly. So that's how we get into all those technologies. Then we got the release cycle going on between Cassandra and MongoDB, each reaching milestones over the years. Then in 2015, Scylla got open sourced, and as an AGPL license, Cassandra reached 3.0, MongoDB as well, then 3.2, where they switched their database engine, how they store data on disk, to WiredTiger on 3.2. So 2015 has been quite a nice year, actually. Then 1 year later, Scylla got 1.0, then the year after 2.0. 2.0 was a counter production ready, if I remember correctly, while MongoDB reached 3.6, which had 2 interesting things. One is change data streams, and the second one was about having the ability to apply a schema to collections. And at this time, we started looking into Scylla as well, because of some kind of workloads that were a pain for us. 2018, MongoDB reached a new and important milestone with 4.0, and they also changed, which is not a nice milestone in my opinion, and Dor has blogged about it, and I encourage you to read his insightful opinion on this. So they switched to a SSPL license. I felt it was worth mentioning. And 2019, MongoDB got 4.2 with distributed ACID transaction through a cluster, and Scylla reached 3.0. As you can see in between these slides being made, and now we have 3.1 as well. So 3.2 was like materialized view production ready, and secondary indexes as well. And 3.1, you already heard about it. So it's a nice progress. Now let's see their architectural differences, and it will be more talking to operation side of those technologies. The first one is the core. They are both written in C++, so that's something that they share and they have in common. They are using and advocating for the XFS file system as well. That's something that they share too. They both have a compaction command that handles low-level and storage-related stuff. Even if it does not mean exactly the same thing, it's about disk space. Then the most important difference is how they handle and pinpoint some workloads to CPUs. MongoDB does not. So you have an unbound core. That means that all the performance and all the things that MongoDB and the engine does is not tied to specific CPUs, while the thread per core architecture of Scylla is doing this. So you have been hearing a lot of it since the beginning of the presentations and the conference. That's the word I was looking for. And I guess you will be hearing a lot more about it afterwards. Security-wise, they both support on-the-wire encryption and encryption at rest and stuff like this. They both have the same kind of stuff on enterprise versions with LDAP, etc. For now, Mongo is still a bit more mature on this side. It has and supports field encryption that is automated on MongoDB Enterprise, so you can actually encrypt one field on the fly. For European-based companies that are running under GDPR, this is something that is sometimes interesting to have. Now, if we go back and we go into the architecture in a purely formal way, we will be comparing a pyramid, and I'm not saying triangle for a purpose, so a pyramid with a circle. The terminology between this is that this pyramid will be called a replica set, so we will be putting nodes around this pyramid and that will form what we call a replica set in MongoDB. While in Scylla, we will put nodes around the circle that will form a cluster. At the top of this pyramid lives a special node, the grandmaster slashing the slaves all day long. No, not really. It's more politically correct, it's called the primary node, which still has some superpowers compared to the others. So at the bottom of the pyramid, there is the secondary nodes that are living, and all form the replica set. It's interesting to note that the data is replicated on all the nodes. So all the data lives on all the nodes, but one of them is responsible and is the guarantee of this data that is coming, and that's the primary node. I'm sorry if my tongue slips sometimes to master, but because at some point it was called like this, but it is the primary that I'm talking about, and secondaries. On the Scylla world, it's more like aligned with human rights, I guess, because all the nodes are born equal, and they all share the workload in the same manner. So there's nothing special about a node in the Scylla cluster. They are all equals, and they are all responsible for a slice of the data set. The amount of the data set that they are responsible for is actually tunable directly through the by T-space, through what you already heard about the replication factor. Okay. If we relate this kind of topologies to the CAP theorem, what we see that this primary node has one major application is to be the guarantee of what is coming inside the cluster or the replica set, because it's not yet a cluster. We'll get there. That means that in the CAP theorem, MongoDB favors consistency. The primary node is the only one of the nodes in the replica set that has the ability to write. That means that all your writes and write throughput will go to only one node of your replica set. How many secondaries you will have doesn't care. The only thing you need to keep in mind is all your writes will go to only one node in a pair replica set. So the secondaries, they are read-only. On the Scylla side, though, all nodes are equals, so they are all capable of reading and writing data. And since they they have their own share of this data, their own share of burden, let's say, you will get a distributed amount of workload between the nodes. So what's interesting is, based on your replication factor, of course, interestingly, from the core, you can see that the design of the distributed hash table, consistent hashing-based circle of the Scylla cluster will help you really balance the data and make it more available. At least it's tunable, thanks to the replication factor. Okay, so now if I look at this and I see the MongoDB replica set, how do I scale those writes? You can scale the writes by adding a new primary node, right? If I add a new primary node, I will be adding actually a new replica set, because I can't have multiple primaries per replica set. So if I want to scale this, I will have to create a new replica set, which means that at some point, I have to split my data set between those replica sets. This is called sharding, and you will have to select a special key, a bit like the partition key on the Scylla world, that will be responsible for this. This means that there must be a place where lives the information of what slice of data lives on what replica set. For this, you will have to create a replica set, which is it's a blue one, that will hold this very information, this configuration or metadata configuration replica set. But then your clients need to know as well when they connect to what is soon becoming a MongoDB cluster, they have to know which node to address. And they can't know by themselves. So you need to add, and that's the little rectangles over there, you need to add a new piece in your topology, which are called the MongoS, or MongoDB routers. They are smart routers that are connected to the config replica set, so they know where data lives, on which replica set it is, and that will route the queries. So you can think of them like the coordinators of a Scylla cluster or a Cassandra cluster. But it's still a new piece that you have to deploy and maintain. And when you have done all of this work, congratulations, you just created a MongoDB cluster. On the Scylla side, if you want to add more throughput, you just add nodes. End of story. Sorry, it's a shortcoming, I know, but that's how it is. Anyway, that's good on one data center. Now, what if I want to spread this or scale it or stretch it to multiple regions and multiple data centers? This is doable on both worlds, of course. I will just have to have a replica set in different regions. I can fairly scale my configuration replica set between the regions as well, every time. I will have local MongoS instances to route my queries locally, and it should work pretty well. MongoDB has this concept of sharding zones that also allows you to make sure that, I don't know, Chinese data stays in the Asian data center. On the Scylla side, it's built-in, so it's something, there's nothing really, really special about it, except the latency between data centers, but that's true for every distributed system anyway. So the replication factor applied to a replication strategy will give you the data location of what you are looking for inside your now stretched cluster and multi-regional cluster. All the rest is done behind the scene for you. So let's look at some takeaways on the operational side. By everything that I told you, I guess that the first thing you need to remember is avoid creating MongoDB clusters. Please. I could write a book on this very topic, on war stories. The main reason why, apart from the complexity, and we'll get there on TCO and ops rating just on the next slide, is the very fact that MongoDB does not bind the workload to CPUs. And the sharding, the distribution of data between replica sets in a cluster is done by a background job named the balancer. This balancer is always running, always looking at how sharding should be done, and always ensuring that data is spread and balanced over the cluster. It's not natural because it's not based on consistent hashing. It's something that it has to be calculated over and over again. And then it splits the data into chunks, that's how it's called in Mongo, and then moves it around. When this happens, this has a direct impact on the performance of your MongoDB cluster, because there is no isolation of this workload versus the rest of your real production workload. And that has significant and very bad impacts. So the TCO of a MongoDB cluster, I've separated both. So the first one is the cluster itself, and the second one is related to replica sets. The TCO is obviously bad. Just to scale, because you needed more writes, you had to create a monstrous topology. You waste resources because all those secondary nodes, they are there. They have I/O available, but you are not using them. And that's bad, in my opinion. On the ops rating, this constant redistribution of data has a really impact on how your overall cluster performs. They offer some time window where you can say, hey, balancer, do not run between peak hours, let's say. But let's be honest, it's just a patch. On the replica set side, though, it should be enough. I mean, the replica set itself is easy to reason with. You might agree or not with the master-slave relationship, but at the end of the day, the TCO is pretty moderate, and there's no shame in scaling up a master node or the nodes inside a replica set itself. I think it's even saner than create a MongoDB cluster. So go for bigger machines, scale up your IOs inside every one of the nodes of your replica set. That's okay. And that relates well with what Glober said just earlier about should I use commodity nodes or bigger nodes, right? The commodity promise in the NoSQL world, I think, doesn't stand anymore. And this is a good example of it. On the ops rating, I think it's really good, actually. There is almost no tuning needed to operate and to set up a replica set, a MongoDB replica set. Automation is then really easy because there are really few configuration options, and the rolling upgrades are really smooth. We never had a single problem of incompatibility when upgrading our replica sets. So it's fine. On the Scylla side, the consistent hashing-based clustering is really, really efficient. It has tricks, sure, but it's really efficient. The TCO is then optimal, in my opinion. It's a clean, simple topology, easy to reason with. you maximize your hardware utilization, and you can scale horizontally, virtually to infinity. The ops rating could be better, I think, and I know the Scylla guys are putting a lot of efforts in making it better. So there are a moderate number of configuration options. If you look at the Scylla YAML, which is a derivation of the Cassandra YAML, you will see that there are a lot of options in it. Some of them are actually not used by Scylla, which is a bit confusing. Some are a bit cryptic, so you don't know. So it's not really, really easy to reason with. Automation could be better as well. There is still this per node manual setup required. Maybe some things could be done a bit smoother. And of course, there are complex and mandatory background maintenance operations, compactions, which is seamless. And since Scylla pinpoints workloads to CPUs, they are able, thanks to the scheduler, to make sure that these compactions do not have a big impact on your workload. And repairs, so unless you work at kiwi.com, I really advise you to do them, please. Okay. So they are semi-seamless because they have put a lot of energy into Scylla Manager, and I'm eager to hear more about what is coming on 2.0. Let's look on the developer's perspective now, which is usually how a database has a lot of traction and becomes popular. So at the core, we are comparing a document store with a columnar store. This document store, it supports geospatial queries, text search, aggregation pipelines, graph queries, change streams. It's rich, it's mature, and it's really efficient. So the sunglasses really goes to the document store. The columnar store has UDT on Scylla, UDT counters, soon lightweight transactions, and thank you for this. And all the other things also that like user-defined functions that Avi mentioned, so we are really eager to see them happening. But for now, let's face it, it's a bit more, it's a bit less, it's limited compared to the document store. So from a developer perspective, reasoning with a JSON object is usually more flexible and feels more natural than interacting with a row. So this relates then to the modeling itself. Mongo has flexible schema. You can start inserting data into your collections, which is the equivalent of a table, in Scylla with no efforts, and nothing will prevent you from doing this. Since 3.6, you can also enforce, and that's what I'm showcasing here, a schema. So there is also the ability to have a schema validation before you insert data, so that you make sure that your data inside your collections are consistent, which is pretty cool, but at least you got the choice. Versus the table schemas, which is fixed. And even if in the Cassandra NoSQL world, altering is fine. I mean, it's almost seamless. This schema is there, it's typed as well, which if you don't apply a schema on your documents, you don't have to type them. So from a developer perspective, the entry barrier is lower on MongoDB as well. Now let's talk about connecting and interacting with the database, which is a very, very important part, in my opinion, also in the adoption and in the image that the database can have to the people that are actually using them and not operating them. Here, the kudos goes to PyMongo. So this is my little minute where I showcase my love for this Python driver, which is, I think, really an inspiration of how a database driver should be. And over the years, the guys behind it, mainly Jesse and Bennett, I think it's its name, have put a lot of energy. And MongoDB, as today, a few years ago, all the CRUD operations, they harmonized how all their drivers interact with the database. Meaning that whether you're using Java Python or Go, if you want to insert something into the database or find and modify something in the database, the name of the function will be the same, and the signature of the function will be the same. It's the only database I know that have undergone this full harmonization on how you developers interact with the database. So kudos to them. It has been and it came from the guys behind PyMongo. So kudos to them for this. It's really cool. Scylla is, for now, relying, and have been relying a lot on the Cassandra drivers. Now we have some shardware drivers as well that are popping. The Java was the first one, maybe, or the Go one. I don't remember. What it means that is usually Cassandra and the ecosystem or clients of Cassandra and the drivers will interact well with Java-based ecosystems, such as Hadoop and Spark. So on this side, I think it's better to interact and easier to interact with Hadoop on the Scylla perspective than it is on MongoDB, because MongoDB has an abstraction, a BSON, which is a binary of the JSON representation that is not native in those world. So it adds a bit of complexity to interact with Hadoop and Spark. So here, the Scylla Java driver, which is shard aware and I encourage you to use, is good. The Cassandra connector, when you interact with Spark, is good. Could be shard, it could benefit from improvements as well. But there is still no shard aware driver on Python, which I think is a shame because data science, as you know, is a growing member of our communities, data communities. So their interaction with database is crucial in their day-to-day work. So the most they can squeeze out of the database, the better it is for them. And this data science world is mainly using Python. So this is my second minute of, please, guys, make it happen. I'm looking at Dor. I think that's you. But he must be somewhere like this, around this. Please make it happen. It's something really, I think, important for our community. Let's see about querying now. All those aspects gives the querying a frictionless querying on MongoDB. It's really easy to issue queries because you're just filtering and interacting with JSON. Okay, so, and we have seen that there are a lot of things that you can do already. Whereas in Scylla, I don't know why I say whereas, because it's also pretty easy to reason with on the Scylla world. There are performance guarantees queries, which means that from the developer's perspective, it has something a bit weird on each of them. When you issue queries on MongoDB, you can issue any kind of query. The database will just accept it. So it's cool, it's frictionless, and you're happy at the beginning, but you don't see that you're actually running a call scan, what is called a call scan. So it's like a full table scan on a simple looking query. So you can end up affecting your production workload by issuing wrong queries that are suboptimal. So that's not good. And that's mostly hidden from you by this nice and shiny flexibility of Mongo. Scylla won't let you do that at all. It will just say, hey, you're asking me to do something that will have unpredictable performance. Please think again. Or add these allow filtering magic words, and I'll do it anyway. So from a developer's perspective, and I know about it because I've been advocating a lot at Numberly with my developer teams. They were like, oh, I would like to issue this, but I'm getting thrown away. I said, it's fine. It's for your own good. It was also for the database good, but anyway, at the end of the day, it's true. So think about your modeling, think about something else, but try to avoid them unless you know, of course, what you're doing. We do actually use a lot of allow filtering queries. Handling consistency, the keyword here is tunable by the client. So that's up to the clients to have their own consistency depending on what it is that they are doing with the cluster. It's just, the principle is about the same. It's how many nodes of my topology should acknowledge the operation that I'm asking for right now. It's called write concern on MongoDB, and it's called consistency level on Scylla. But you can generalize that it's basically the same idea, and that it's the client's responsibility to actually choose about this. Again, unless you work at Kiwi, do not forget repairs, please. Repairs, and a lot of people can explain this better than me, they can, if you forget them and you delete data, they can lead to resurrected data. And I know, even if it's Halloween season, you don't want zombie data in your cluster, please. So do not forget repairs. Data expiration now. You can expire data on both systems. On MongoDB, it's done by adding a special field that is meant just for this, that you will create a special index with an expire after second option that will tell MongoDB, hey, this data can be deleted at this time. So the cost of handling TTL in Mongo is actually an index and a special field, which is okay most of the time, but it still has a cost. Remember it. On Scylla side, all of this is already included because it's part of the metadata that is collected by column. So you can have a general TTL on the table definition, or you can set it on insert update. It's pretty easy to reason with, so you can expire a column or you can expire a row, whereas Mongo will just expire the whole document. It's interesting to note that you can query the TTL. There is the TTL function that allows you to query the expiration of a certain column. It doesn't work on primary and clustering keys. Another thing interesting is that in this metadata, you also get free write timestamps. So a lot of people usually have a special field for this, like created at, right? That we keep on our data models, and you can see them about everywhere. It's of course a really valid use case, but just in case you didn't know, you have this write time function in Scylla that will give you this for free because it's part of the metadata. So if we sum up a bit on the developer perspective, what we can see and fairly say is that MongoDB favors flexibility to performance. It's easy to interact with. It will not get on your way, basically. So it's pretty cool, but it will have impacts on performance, of course. It's still NoSQL world, so impacts on performance. If it's millisecond and it's okay for you, it's fine. But it's not always the case for every workload. Scylla, on the other hand, it favors consistent performance to versatility. So it looks a bit more fixed, a bit more rigid on the outside, but once again, that's for your own good. And so you can have consistent performance and operate well and interact well with the system. This makes, in my opinion, a real difference when you have a lot of workload that is latency and performance sensitive like we do. The list is not full, okay, but it's good that we now have efficient server-side filtering. Since 3.0, this allow filtering got a lot improved, and its footprint on the usage of the cluster has dramatically reduced, so it's good news. Row-level repairs that just got announced. We are going to have in 3.2 a simple but yet efficient like operator, so you can finally do like something and use special combos and globes inside queries to look into a text field. So that's something that actually we have been asking the Scylla guys to implement, and they pretty quickly did it. So thank you again for taking our requests into account and making it happen. It's going to help us a lot, because for now we are doing it on the application side. And it's leveraging on the efficient server-side filtering that was implemented in 3.0. Lightweight transactions, of course, if you are a Cassandra user, you have been expecting it for a long time. I was really happy to see that we will get 2 flavors of it. I was expecting the Raft one, but not the Paxos one, so it's really cool. Change data capture for everyone who interacts with Kafka, for instance, like we do. It's really, really important, and that's something that we have been waiting for a while, to be honest. UDFs and so on. I guess we have a lot of nice news and that will be provided along the conference. Still missing index intersections. So this is something that I know they are going to work on, because today you can have multiple index, but the way they are chosen by the engine in Scylla is not always optimal, and things could be better there. Once again, sorry, but a good and shared Python driver, please, please, please. And it's asynchronous too, using async.io. And search capabilities. So last year they promised it was something that they had in mind. So I'm taking their word for it, and I'm looking forward to hear more about search capabilities of Scylla, because for some easy things, it might be handy not to have a separate elastic thing to maintain, and another nightmare. In the end, that's actually a great NoSQL combo. So it's not a deathmatch after all. We are happy users of both. You just have, and we are happy because we select the use cases based on their strengths. Let's get into some of those use cases at Numberly. MongoDB is very strong in web backends and real-time queries over unpredictable behavioral data. So we get fed with data that comes from, let's say, web tracking data, and that is implemented from our clients' perspective, so in their website. So every time someone visits their website, we get a call out of it. It's cool, but we don't have a strict manner to impose a schema on this. And we still need to be able to query this data, to look at what it looks like, and to do some operations on it. And because we are real-time pipelines taking actions based on what they see. This is where Mongo is, and flexibility is good for us, because it allows us to just store it somewhere and query it. Fine. On the Scylla side, we'll use it for real-time and, of course, latency-sensitive data pipelines. So that is most likely data enrichment, where you have multiple sources of data and you want to correlate them in real-time on pipelines. So that's tricky to do and latency-sensitive. We also mix a lot of batch and real-time workloads in Scylla, because it gives us the best of both worlds. So that's the talk I gave last year, and that was explaining how we had Hive on one part and MongoDB on the other, but we put everything in Scylla, and they could be sustaining Hadoop-like batch workloads and real-time pipelines workload. So that's where Scylla is shining at Numberly. And also, more and more of our web backends are done in GraphQL, which imposes as well a schema. And in this case of having a schema-based API, having a schema-based database with low latency and high availability is really good. So a lot of our backend engineers and front-end as well, since GraphQL fills the gap, are really cool adopters of Scylla. We see the trend, to be honest, really into Scylla today. So we have more and more adopters at Numberly, and more tech people coming and asking, hey, I have this use case, would it fit? And would it be fun to start using it on Scylla? And most of the time, the answer is yes. So the Scylla adoption is still growing. MongoDB is flat, but it's still here to stay because it has some really interesting features as long as you don't do a MongoDB cluster, please.